Hi, in this video, I will be showing you problem number 30 of chapter 10 section 4. Find the area of the region that lies inside both curves r equal to 6 plus cosine theta and r equal to 6 minus cosine theta. We have to sketch both graphs 6 plus cosine theta and 6 minus cosine theta and see what graph comes up in the middle, which is the intersection of these two, and we have to find out the area of the intersection. As we normally do when we do the polar graph, we first do the Cartesian graph, and translating the Cartesian graph to polar graph will be much easier. So 6 plus cosine theta is the cosine theta graph shifted above 6 units, so which is what's shown in the red graph. I translate that to polar graph. So the graph on the right hand side graph, the one that is shown in red is 6 plus cosine theta graph. That's what I've shown, the first one. And then same way we have to do the Cartesian graph of 6 minus cosine theta, which is the inverted cosine graph shifted above 6 units, which is what's shown in this graph. And then I translated that into the polar graph on the right side, which is shown in green, which is 6 minus cosine theta. Now the question is to find the area between the two graphs. It says in the problem we have to find out what is the area inside both curves. So that is the area we are going to find out. So inside both curves, this is the area that we want. As the area is symmetric with respect to the theta axis and the r axis, as it is symmetric now, it can be considered as 4 times the area of this part. So 4 times the area of this part is the entire area required. So it is symmetric, and we can consider now, if you consider only the 4 times of this part, and this part is made up of only the green graph, the green graph is 6 minus cosine theta. So we can write the required area inside the two curves, or the intersection of the two curves, is area equal to 4 times area of one piece, which is 0 through pi by 2, half r square d theta. So it will be 2 integral 0 through pi by 2 r square, where r is the green graph, so 6 minus cosine theta the whole square d theta. So that will be 2 times 36 minus 2 times 6, that will be 12 times cosine theta plus cosine square theta d theta, but theta lies between 0 and pi by 2. So 36 theta minus 12 sine theta. If you integrate the first two terms, which need to be evaluated between 0 and pi by 2, the other integral cosine square, can be written as 1 plus cosine 2 theta over 2. Very often we will be integrating either sine square or cosine square in these problems. In both cases you have to apply the trigonometric formula. For cosine square it is 1 plus cosine 2 theta over 2. If it was sine square, you have to use 1 minus cosine 2 theta over 2. 0 through pi by 2 d theta. So this will be evaluated. So area equal to 2 times, substitute now pi by 2. So it is 36 times pi by 2 minus 12 times sine pi by 2, which is 1. At the lower limit it is 0. Then we have 1 half taken out. Then it is theta. Integral of 1 is theta. Integral of cosine 2 theta is sine 2 theta over 2 between the limit 0 and pi by 2. So area equal to 2 times, this will be 18 pi minus 12. Then you have half outside. Now you plug in the upper limit, which is pi halves plus sine of 2 times pi by 2. That will be a sine pi, which will be 0. The lower limit, it's all 0. So it's going to be just pi by 2 minus 0 at the lower limit. So it is 2 times 18 pi minus 12 plus pi by 4. If we combine the two pi terms over here, 18 pi plus pi by 4, that will be 72 pi plus pi over 4, that is 73 pi over 4 minus 12. So it is 2 times 73 pi over 4 minus 12. In other words, it is 73 pi over 2, if you distribute the 2, minus 24. This being area, you can say that this is unit square. So this is the area inside these two curves, the curve of intersection of these two polar curves. Hope this video helps.